Mapping and software engineering. Software engineering is in a terrible pickle. The so-called software crisis was identified in 1968, but despite 30 years of effort, with hundreds of supposedly fundamental concepts published, the general state of the industry is horrific. Projects run massively over budgets or collapse entirely in unrecoverable heaps. Estimating is a black art, and too many projects solve the customer's problems of yesterday, not today. The technical quality of most code is dreadful, leading to robustness problems in service and high maintenance costs. And yet, within the industry, there exist individuals and groups who enjoy staggering, repeatable successes. A few years after these documents were written up, a bunch of head programmers gathered in Snowbird, Utah, having all realized that staggering and repeatable success was possible. That event resulted in the Agile Manifesto and its collection of methods. While these methods no doubt hold some usefulness as they have become the industry standard, there are nonetheless some doubts. What they have helped deliver is nothing short of a miracle, but even that lies far from what they themselves have achieved in their personal progress as programmers and in creating their highly effective as well as productive teams. There are many ways of measuring the usefulness of programmers, but some are rated as over 100 times more useful than most by several methods of counting. If only the whole of the industry performed as well as the tiny minority of excellent workers, the economic benefits would be immense. If it were possible to write sophisticated and reliable software quickly and repeatably and cheaply, the intelligence of society would increase as everything from car sharing to realistic social security regulations became possible. Within this model, the problem can be understood. What is presented as socially conditioned conventional thinking called packing is based on action. To be a good bricklayer, a packer must know what a bricklayer does. What does a programmer do? The most developed packer model of programming is the concept of a software factory. In this, statements of requirements from customers go in one door and are processed by workers following procedures written down in manuals. When the production line has done its work, programs come out the other door. Well, it works in car factories. The trouble is, the analogy with a car factory is sloppy. Most of the car factory is filled with workers using machines to make cars, but around the back there is a little office where another worker determines how to use the resources of the factory to make as many cars as possible, all alike. The workers in a software shop are not like the factory floor workers. The shop floor workers can be replaced by robots today, but the person who uses creativity to set up the factory is still needed. The programmers are doing the same job as the office at the back of the factory, and we cannot learn anything about what happens in there by observing the car factory shop floors. To understand what programmers really do, an alternative strategy of thinking called mapping is necessary, because programming is essentially a process of internalizing the capabilities of the system, the nature of the problem, and the desire, and capturing the insight in a programming language. It is all about exploring the details of the desires and understanding them in such a way that we can keep track of all the complexity. Map a problem called apps can produce beautiful, tiny, elegant programs with no room for bugs in them. Mapping can do programming, but how does it do it cannot be explained in Packer's action-based language. Packers therefore assert that hackers are irresponsible and discount their work, saying that complexity is inherently not understandable, and we must develop ever more complex procedures to abdicate our responsibility to. Fortunately, many organizations' management continues to foster reflection on grounds of personal intuition and empirical experience, without any justifications to place in action-based balance sheets. This is a difficult thing to do, but it's the only reason anything gets done. It is important to recognize that mapping is not another procedural methodology to be applied to a Packer mindset. It is a different way of looking at things altogether. It is necessary to convince yourself that it is really possible to take personal responsibility for an undertaking instead of abdicating in favor of a procedure. Programming is as near to pure mapping as you can get outside your skull. This is why it's fun. It is an endless discovery, understanding and learning. Object orientation and mapping have an interesting relationship. OO is often seen in very different ways by mappers and packers. The mapper's map is a kind of object model that is rich in variety of objects and associations. Mappers see OO as an elegant way to design software once they have understood the problem. Packers seem to see OO as a way of wandering around the problem domain and creating software objects, then just wiring them up as they are found. Thus, OO is taken to be a procedural mechanism for getting from one problem to a program without the intervening understanding. If it were possible to capture absolutely every aspect of the problem domain and one did not care about efficiency, this approach might even work. But in fact, good taste is always needed in object design and categorization because it is necessary to design software objects that have a good mapping with real-world objects, but can be plugged together to construct a viable computer system. That takes understanding and, to put it strictly, a mapper's job. This explains the OO projects that grind to a halt with a product, a tangle of real and utility objects using multiple redundant addressing schemes to communicate via object request brokers, with no clear conceptual integrity in instantiation, flattening and journaling. Packer programmers often have so little control over their objects that they lose them and end up with memory leaks that cause the application to fail. The Packer solution to this is to buy a memory leak detection tool rather than to regain control of the objects, so that everything else works properly too.